right, so now they're going to give us pretty much every property of real number known to man. Not quite, but they're going to go back through these properties that you learned in middle school and you learned in Algebra 1 and you learned in Algebra 2. I'm not going to require you to match these on a test or anything like that. We need to be able to use these. So in just a minute, when we say, hey, we need to use the distributive property here, if you don't remember what the distributive property was, you have a master list that you can go back to find what that is that we're talking about, okay? So they also give us some terminology that is helpful that we'll use frequently. All right, so for instance, constant and variable. What's a constant? Any number, okay? Something that stays the same. What's a variable? Something that changes. So, fun fact, is God a constant or a variable? Constant, thank heavens that I don't go to him and go, oh God, I have this issue. And he's like, not really feeling it today. Tomorrow's not looking good for you either. So, I mean, what would we do if we didn't have him to depend on? I think we just kind of take it for granted. The Bible says that there is not even a shadow of variance with him. So he definitely does not vary. He is a constant we can depend on. Algebraic expressions is just if you put constants and variables together with adding, subtracting, multiplying, dividing. So kind of like this little guy down here, the 2x minus 7, that would be an algebraic expression. Terms are just each of the parts of the algebraic expression, so like the 2x and the 7. Like terms are ones that we can combine. They have the same variable and the same exponent. Equations are two quantities that are equal to each other. Root word of equation, equa. So two things that are equal to each other. Formula like distance equals rate times time, something like that we can utilize to solve real world situations. And then simplifying an algebraic expression, we're going to do that in just a minute, where basically we take things like the 2x minus 7, bless you, that have other pieces with them, and we simplify them down. Or so that's what they mean by simplifying the algebraic expression. Okay, so it asks us to list the variables and the constants for 2x minus 7. So what's your variable in 2x minus 7? X. And what are your constants?
2 and 7.
2 and negative 7, yeah. So we also sometimes refer to the 2 as like the coefficient, the number in front of the variable, leading coefficient if it's the number out in front. So that's some more terminology that we will encounter in the very near future. All right, so then they asked me to evaluate 2x minus 7 for some specific values, okay? So for this first one, it says evaluate 2x minus 7 when x is equal to 0. So what do they want you to do? Plug in 0 in the place of what? X, exactly. So let's put 0 in the place of x. So if you put 0 in the place of x, what are you going to get? Yeah, so you're going to get 2 times 0 is 0, and then minus 7, so negative 7. Now, again, you can probably do that in your head, and it took me 4 lines to write it, right? So you do not need to write down, even on your test, you don't need to write down nearly the work. If you can do that in your head, that's perfectly fine. I just want you to be able to look back at it and understand exactly what we did. All right, so for the next one, x is equal to 1. Let's put 1 in the place of x. So if we put 1 in the place of x, what are we going to get? Negative 5. Try that next one, 1/2. Put 1/2 in the place of x. See what you get. You can do it in your head or you can write it on paper, either one. And if you're finished with that one, go ahead and try the negative 4. All right, what'd you get when you plugged in 1/2? All right, so we had 2 times 1/2 is 1, minus 7 would give us negative 6. And then for this last one, we had 2 times negative 4 was negative 8. And then minus 7 would give us negative 15. All right, so this next one is that simplify an algebraic expression we were talking about a minute ago. You can see this is an algebraic expression. It's just constants and variables added, subtracted, multiplied, divided, okay? And they want us to simplify. So what are we going to do first? Distribute. So that thing we said about, you know, if we say, hey, let's use the distributive property, and you're like, wait, what is that again? You've got that master list that you can go back to, okay? But for distributive property, we're going to take this negative 5, and we're going to distribute it to the 3, and we're going to distribute it to the negative r. So negative 5 times 3 gave us negative 15, and negative 5 times negative r gave us positive 5r. All right, what is a like term with the 2r? 5r. Remember, it has to have the same variable raised to the same exponent, and then, of course, our constants are like terms. So if you combine 2r and 5r, you literally have 2 r's and 5 r's, and when you put them together, what do you have? 7 r's. You just combine the coefficient. You leave the variable and the exponent exactly the same. The most common mistake that people make here is they say 2 and 5 is 7 and r is r squared. I mean, think of it as I have 2 apples and 5 apples. I put them together, I have 7 apples. I don't have any squares at all, right? So again, we're just going to combine the coefficients and leave the variables and the exponents the same. And then, of course, combining our constants there. Now, they might also, in WebAssign, give you something like this and say, solve it. Okay, well, after you simplify it down to 7r minus 11, then you can just solve it, add 11 to both sides, divide by 7, getting r by itself. So we're good at solving. We have done that for just a little while. All right, and then the next thing that we want to review are your rules of exponents. All right, when your bases are the same and you're multiplying, what do you do to your exponents? Add them. When your bases are the same and you're dividing, what do you do? Subtract. When you have a power raised to a power, what do you do? Multiply. An easy way to remember that is the parentheses, because we usually think of multiplication when we see parentheses, so that might help you remember power raised to a power, you multiply. All right, then you'll notice in the next two, if you have a quantity raised to an exponent, each of those values gets raised to the exponent. It doesn't matter if they're being multiplied or they're being divided. Each of those values is going to get raised to that exponent. All right? Then anything to the 0 power is 1, with the exception of one thing. There's something that if you raise it to the 0 power, it's undefined. You know what that is? 0. 0 to the 0 power does not exist. Put it in your calculator, it'll give you an error message. But anything else to the 0 power is going to be 1. All right. And then this last one, our negative exponent rule, it just says that right now that a to the negative m is over 1. Any whole number we write over 1. So to get rid of the negative exponent, you move across the division bar. So that was a to the negative m over 1. When I move across the division bar, and I move that down to the denominator, notice the negative exponent goes away. So here's another example. If you have x to the negative 2, that's over 1. So to get rid of the negative, you move across the division bar and it goes away. Now, that also works if you have a negative exponent in the denominator. You also can move across the division bar and get rid of your negative exponent. All right, so let's look at a couple of those. All right, so for the first one, everything inside these parentheses is being raised to the negative 3. So the first thing that I'm going to do is I'm going to write it that way so that I can see it. I'm going to write each one of those values to the negative 3 so I don't accidentally forget to maybe use my number to the negative 3. All right, so how do we get rid of the negative exponent again? Right now that 2 is over 1. How do I get rid of the negative exponent?
Under 1.
Flip it, yeah. So all I'm going to do is move it across the division bar. So I'm going to say 1 over 2 to the positive 3. So when I move it across the division bar, the negative exponent goes away. Now, use that as an example to see what to do with the variable. If you have u to the negative 3, it's the exact same idea. That u is over 1. So to get rid of the negative exponent, move it down to the denominator across the division bar, and it becomes positive 3. All right, then what do I do when I have a power raised to a power again? Multiply. So negative 2 times negative 3 is where we're getting that positive 6. All right, so then we can just combine our numerators. So 1 times v to the 6th, and 2 cubed, 8, times u cubed. All right, look at the next one. So for the next one, what do you do when your bases are the same and you're multiplying? You add them, yes. What is the exponent, or what is the power on x? 1. So don't forget about that one. When you go through and you add your exponents, our bases are the same, we're multiplying, so we're adding our exponents. Don't forget when you do that, you need to add the 8, the negative 12, and the 1, all right? So if we add the 8 and the negative 12 and the 1, we'll end up with x to the negative 3. Then go ahead and rewrite that without the negative exponent. Get rid of the negative exponent. So what is it without the negative exponent? 1 over x to the third. Move across the division bar to get rid of that negative exponent. All right, how we doing? Everybody good? All right, so then this next one gets a little more interesting. All right, so for this next one, we're kind of putting together several of the ideas that we were looking at. So again, you can see everything in this numerator is getting raised to the 4th power. That was just like the A part that we did on this example. Same thing down here. Everything in the denominator is being raised to the 2nd power. All right, so let's go through and let's take each one of those pieces and raise it to its exponent. All right, so to begin with, we had 2 to the 4th. What is the new exponent on h going to be? So I have h squared to the 4th. What would that be? H to the 8th. And then I have k to the what? 4th. In my denominator, that 7 is getting squared. So then let's look at our h. If you have h to the negative 1 squared, what's that going to be? Negative 2. And then you have k to the 2nd squared. What is that going to be? K to the 4th. All right. Now I'm going to break these up where I have like my numbers together, my h's together, and my k's together. So I can just kind of focus on one thing at a time. So I'm going to put my numbers together, then put my h's together, and put my k's together. All right, so 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16, yes. And then 7 squared is 49, so we're good with that first piece. All right, then for the second piece, what do you do when your bases are the same and you're dividing? Subtract. So we're going to do 8 minus a negative 2. So it's 8 minus a negative 2? 10. So we're going to have h to the 10th. And then k to the 4th over k to the 4th, those just cancel each other out. Or you could think of it as 4 minus 4 is 0. So k to the 0 is 1, whichever you like better. So then in our numerator, we have 16 times h to the 10th. And in our denominator, we've got 49. So simplifying with exponents. The last thing that we want to look at is another way that we use positive and negative exponents, and that is to help us with scientific notation, taking really large numbers and making them easier to work with, or really small numbers, either way. Now, you do scientific notation in science with significant digits and all that kind of stuff. We're not going that in depth. We're basically just brushing the surface with this. But when you're working with scientific notation, I'm going to rewrite this great big huge large number so that this first digit is between 1 and 9. So I would have to write that as 2.4 in order for that first digit to be between 1 and 9. All right, so that means that my decimal was here at the end of my number, And I have moved it all the way up here in between the 2 and the 4. So I need to count how many decimal places that is. So if I go through and count, literally starting at this end and saying, okay, I've gone 1, 2, 3, 4, 5, 6, we get the idea that it has moved 19 times. So if I have scientific notation raised to a positive exponent, it's going to make that number bigger. But over here, you'll notice that I have scientific notation raised to a negative exponent. That's going to make the number smaller. So this time they're giving me the scientific notation and asking me to come up with a standard notation. All right. So to do that, we said that that number was going to get smaller. So my decimal instead is going to move 6 places. 1, 2, 3, 4, 5, 6. It's going to be right here. What do I do with all those empty spots?
Zero.
Put in zeros, yes. So I'm going to put in 0 placeholders. And so that's how I can go back and forth between my scientific notation and my standard notation.